All right, let's take a look at the parts of an atom. There are three main parts of an atom. These are called subatomic particles. And we have protons, neutrons, and electrons. I'm sure you've heard of them before, but now we're going to go into a little bit more detail about them. Protons are the subatomic particle that determine the identity of an element or an atom. So every single atom of carbon has exactly 6 protons. Every single atom of phosphorus has exactly 15 protons, if I can see correctly. Every single atom of hydrogen has 1 proton. That is what makes it that particular element. All protons have a +1 charge, so they have a positive charge, and they have 1 AMU. This is their mass. AMU is atomic mass unit. This is not a very user-friendly unit. We will look at mass later on in a different with a different unit, but right now we're just looking at comparing protons, neutrons, and electrons. Neutrons can vary depending on isotopes, and we'll talk about isotopes later on. They're just different forms of the same atom. So there are different forms of carbon atoms. The carbon atoms still have the same number of protons because that's what determines that they are carbon, but they might have different numbers of neutrons. And we'll look at how to figure out how many neutrons there are in a given atom as well. Neutrons have a 0 charge. They are neutral, okay, but they do have about the same mass as protons, 1 AMU. All right. Electrons, they can vary depending on charge. And we'll look at that in more detail later when we start going through chemical reactions and equations and looking at compounds as well. But that is essentially what will change in an atom when you have different numbers of electrons is the charge, whether you have a positive atom, which is called a cation, or if you have a negative atom, which is called an anion. Electrons have a -1 charge. Okay, so protons and electrons are the ones that balance each other. However, while protons have 1 AMU, electrons have essentially very small mass, negligible, 1/1800th of a proton. So there's really not very many situations where you would have 1800 electrons for every 1 proton to balance out that kind of mass. But so we really just consider electrons to not have much mass at all. Okay. Protons and neutrons are both found in the nucleus. And the nucleus is an extremely dense area in the center. So many people have seen atoms drawn like this. And this area in the center is the nucleus. That nucleus is where the protons and the neutrons would be. The electrons are in the outer rings, or the orbitals. So we'll talk about orbitals, but these are probability functions, probability. In these orbitals is where you have a good chance of finding an electron. It's very difficult to pinpoint a single electron, or really any electrons, but we can determine a location where they are likely to be found. And these locations are called orbitals, which we'll look at later on. In the next video, I'll show you how to use the Bohr atomic model for hydrogen that is in your reference pages. So make sure that you have that out once you are watching the video.